Hey everyone, and welcome back for another deep dive. Today we're looking at software product lines, SPLs for short, and we'll be focusing on a process called IsiSPL,
Glad to be here. Sounds like we're exploring ways to make software development more efficient.
especially right when you're building a whole family of related products.
Yeah, exactly. That's where SPLs come in. And from the research you sent over, it seems like ISISPL offers a really cool way to do it,
Yeah.
particularly for smaller companies or teams.
Okay, so instead of starting from scratch every time we build a new software product,
Right.
we can use SPLs to kind of streamline the process.
Absolutely. It's kind of like how a car manufacturer works. They don't design a totally new car for each model.
Oh,
They
interesting.
have like a platform, a foundation, the chassis, the engine, those core components,
Hmm.
and then they just customize it to create a sedan, an SUV, a sports car.
Oh, I see. So SPLs let us do something similar, but with software.
Exactly. You build that core platform with shared components, and then you build upon that to create variations.
Though less reinventing the wheel every single time.
Yeah. More like swapping out tires or adding some cool features,
You
right?
like that analogy. Okay, so that's where ISIS-PL comes in.
That's it. ISISPL is this process, this method to automate a lot of the work involved in building and managing these SPLs.
It takes care of all that for you.
Well, a lot of it, imagine, right, being able to just analyze your existing software products and then boom, automatically identify the reusable parts
Yeah.
and then generate a platform where you can just mix and match features to create new products. Pretty neat, huh?
Okay, that does sound pretty neat. But before we jump into all the details of ISIS-PL,
Sure.
can we talk a little bit more about the basic principles behind SPLs themselves?
Of course,
In
yeah.
the research I saw, like mass customization and systematic reuse mentioned a lot.
Right, right. Those are the two big ideas behind SPLs.
But what do they actually mean?
So mass customization is all about creating a variety of products, right? But from a common base, a common starting point. Think about like Amazon. You can buy almost anything there.
Yeah, pretty good.
Books,
Yeah.
electronics, clothes, groceries, everything. But it's all from the same platform. That's mass customization in action.
Ah, okay.
Each product is tailored to what you need, but they all share that core infrastructure.
So in the software world, that would be like using a core set of components to build a bunch of different applications,
Yeah.
each one tailored to a specific user or market.
Exactly. Now, the other side of the coin is systematic reuse. This is about using shared components to avoid doing the same work over and over again. It helps speed up development.
I see. So it's more efficient.
Way more efficient. Like using prefabricated building blocks. Instead of making every brick individually, you have these standardized units that you can just assemble in different ways.
So like instead of writing code for, let's say, a payment gateway from scratch for every single product,
Yeah.
we can just reuse that same code across multiple applications.
Precisely. We call those reusable components artifacts, by the way.
Artifacts, okay.
And by systematically reusing these artifacts, you save a ton of time and money. Plus, it's less error prone and makes maintenance way easier.
Makes sense. Okay, so mass customization and systematic reuse. Got it.
Yeah.
Now, there's also this term variability that keeps popping up.
Oh, right, yeah.
What's that all about?
So variability is what lets us create all those different products from our common platform.
Uh-huh.
It's about the differences between those products within the product line.
Okay.
Some components, those artifacts we talked about, are common to every product, right? They're like the core building blocks that give the product line its identity.
Like that payment gateway example. That'd probably be a common artifact in an e-commerce SPL, right?
Right. But then you also have optional artifacts, right? Components that are only included in some products, not all of them.
Oh, okay.
These optional artifacts are what let us customize and differentiate, things like user reviews or loyalty programs or like those advanced search filters.
So variability is about understanding which features are essential, which are optional, and how they can all be combined to create different product configurations.
Exactly. And figuring out how to manage this variability is really, really important for a successful SPL.
Gotcha. So we've got these core principles, mass customization and systematic reuse, and then we've got this concept of variability,
Right.
which lets us build all these variations from that shared base, kind of like building a Lego castle, right?
Mhm.
We've got our standard bricks, but we can arrange them in different ways to build towers, walls, moats, you name it.
That's a great way to put it. And that's where ISISPL comes in.
Okay, how so?
ISISPL gives us this automated way to analyze your existing software products,
Uh-huh.
identify those reusable artifacts,
Right.
figure out that variability,
Right.
and then generate a configurable platform that your developers can use to build new products quickly and efficiently.
Okay, now I'm really interested. So how does this ISISPL process actually work?
Well, IsiSPL has three main phases: integration, analysis, and platform generation.
All right, let's break those down. What happens in the integration phase?
Okay, so in the integration phase, IsiSPL takes the source code from your existing software products and it basically starts breaking it down, kind of like reverse engineering, but
Got it.
instead of taking apart a physical object, we're dissecting code.
So it's like taking apart those Lego creations, separating all the bricks, and sorting them by type and color.
Exactly. And to do this, IsiSPL uses these things called abstract syntax trees, or ASTs.
ASTs, all right. What are those?
Basically, they represent the code in a way that's easier for a computer to analyze. So instead of focusing on how the code looks visually, the formatting and all that, ASTs capture the underlying structure, the logic behind it.
So it's not about the aesthetics, it's about the relationships between the elements of the code.
Right, yeah. The variables, functions, loops, all that stuff. And then ISISPL uses those ASTs to create another data structure called the RT, which stands for artifact tree. This is where all those reusable components, the artifacts, are organized.
Kind of like a family tree of code.
Yeah, exactly. Each artifact has its own branch, and you can trace it back to see where it originated. And to keep track of everything, ISISPL gives each artifact a unique ID. This helps us follow them across different products, see how they've been modified, and understand their relationships with other artifacts.
Okay, so we've taken apart the code, identified the reusable bits, organized them into this RT, and given each piece a unique ID. What happens next?
All right, so now we move into the analysis phase. This is where things get really interesting.
Okay, lay it on me.
So in this phase, we need to figure out the relationships within our software product line, like which features are always used together or if certain features exclude others. And we also want to pinpoint exactly where each feature is implemented in the code.
That sounds pretty complex.
It can be, yeah. But ISISPL uses some pretty powerful techniques to do this, specifically formal concept analysis, or FCA, and relational concept analysis, or RCA.
FCA, RCA, those sound a little intimidating.
Oh, they're not as scary as they sound. Imagine you're looking at shopping carts in a grocery store. You notice people who buy diapers often buy baby wipes, right?
Sure, makes sense.
That's a pattern, a relationship between items. Well, FCA does something similar with software features and artifacts. It helps us identify which features and artifacts tend to show up together in different products.
So if we see that the code for a shopping cart feature always goes hand in hand with the code for a payment gateway feature, that tells us those two features are connected somehow.
Exactly. And FCA goes even further. It also helps us figure out any constraints between those features. For example, it might discover that a premium membership feature always requires a user login feature. Or maybe offering free shipping makes a shipping calculator feature unnecessary.
Interesting. So FCA gives us this deeper understanding of how our features can and cannot be combined.
Right. And then to connect those features back to the actual code that makes them work, we use relational concept analysis, or RCA.
Okay, and RCA helps us. How?
Think of RCA as building upon FCA. It adds traceability, meaning we can trace a feature all the way back to the specific lines of code that implement it.
Oh, that's cool. So if I wanted to tweak the user login feature, RCA would point me to exactly where I need to look in the code.
Right. Now, to do all this analysis, ISISPL uses things called formal contexts. These are basically tables that show the presence or absence of each feature and artifact in each product.
So it's like a giant spreadsheet with products in the rows and features and artifacts in the columns.
Yeah, something like that. And these formal contexts are the input for FCA and RCA, and you know what the output is.
What?
These really cool visual representations called AOC posits.
AOC posits. Okay, that sounds complicated.
I know the name is a bit of a mouthful, but they're actually pretty straightforward. They're basically visual maps that show us the dependencies and the variability in our software product line.
So we can look at one of these AOC posits and see which features are always present together, which ones are optional, and how they all relate to each other.
Exactly. And remember those traces we talked about, those connections between features and code? Well, ISISPL extracts two types of traces from these AOC posits: body traces, which point to the code that directly implements a feature, and interaction traces, which point to the code that manages how multiple features interact with each other.
So like if we had a feature where users could share their profile picture on social media, the interaction trace would highlight all the code that makes sure the sharing works properly with both the profile picture feature and the social media feature.
You got it. To illustrate all this, let's think about that printer example again. We had product PX with scanning and product Pi, which was a color printer.
Right. And we want to combine them into an SPL.
Yeah. In the analysis phase, IsiSPL would create formal contexts for features like scanning and color printing and for all the code artifacts from both products. Then FCA and RCA would go to work analyzing the relationships between those features and code snippets.
So we'd end up with these AOC posits that show us, for example, which code is specific to the scanning feature and which code is shared with color printing.
Exactly. And this analysis isn't a one-time thing. As you add more products to your SPL, IsiSPL keeps refining those relationships, making the platform smarter and more adaptable. It's constantly learning and evolving.
That's amazing. But, with so many features and interactions, don't those interaction traces get really messy?
Oh, absolutely. It can get really tangled, which is why IsiSPL has this step called trace reduction.
Trace reduction, what does that do?
It simplifies those complex interactions, making them easier to understand and manage. It's like pruning a tree to keep it healthy and productive.
Makes sense. So we've integrated our code, taken it apart, analyzed all the relationships, and streamlined those connections. What's the final step in this whole ISIS-PL process?
The last step is platform generation. This is where all our analysis is turned into a usable platform that developers can actually work with.
All right, let's talk about that.
Yeah.
Okay, so we've broken down our software, analyzed the features, the relationships, everything, and we've even, what was it?
Trace reduction.
Right, trace reduction.
Yeah.
To simplify those connections. So it's like we took our Lego castle completely apart, examined every single brick, and now everything is organized perfectly. What do we do now? Do we start rebuilding?
Yeah, pretty much. The platform generation phase is where ISISPL takes all the information, all the knowledge from the analysis, and uses it to build the foundation for our software product line.
So it's like taking those neatly sorted Lego bricks and using them to create like a master blueprint for the most awesome adaptable castle ever.
Exactly. And the best part is ISISPL does all this automatically.
No more manual coding.
Well, there's always some level of coding involved, but ISISPL handles a huge chunk of it for you, especially the tedious and repetitive parts.
That's a relief. So how does it actually build this platform?
It uses what's called the annotation approach.
Annotations, okay. What are those?
Think of them as little tags or markers within the platform's code. These annotations act like switches, you know? They control which parts of the code are activated when you build a new product.
So if I want my castle to have a drawbridge, I flip the drawbridge switch on, and the instructions for building a drawbridge are included.
Exactly. And if you don't need a drawbridge, you just leave the switch off.
That makes it super flexible. Developers can pick and choose the features they want, and the annotations make sure the right code is used.
Yeah, but there's a potential issue here. If we have too many annotations, the code can get really messy and hard to understand.
Right, I could see how that could become a problem. Too many switches, and the blueprint becomes overwhelming.
Yeah, it's a common problem with annotation-based approaches, sometimes called the hell of Eiffels.
Okay, so how does ISIS-PL deal with that?
Well, first, it optimizes the placement of those annotations. They're only added where absolutely necessary, so no unnecessary switches.
Got it. Keep it clean and simple.
Right. And then ISISPL also uses a technique called annotation reduction.
What does that do?
It removes any annotations that are redundant or not actually needed. It's like having a super meticulous architect who's constantly refining the blueprint, making sure it's efficient and easy to understand.
So it's cleaning up after itself, basically.
Yeah, exactly. So in the end, we have this configurable platform that's ready to go. Developers can choose the features they want, and the platform does the rest.
That's amazing. ISIS-PL really does seem like a game changer, especially for smaller companies who, might not have the resources to do all this manually.
It definitely levels the playing field. And the benefits go beyond just the automation, You also get much finer control over feature implementation. Plus, that in-depth analysis we talked about ensures that the platform is well structured, making it much easier to maintain and evolve over time.
This has been a truly fascinating deep dive. ISIS-PL really does have the potential to revolutionize software development.
Just imagine, what if building software was less about writing new code from scratch and more about selecting and assembling pre-built components?
Kind of like having this giant Lego collection and being able to build anything you can imagine.
Exactly. And ISISPL gives us a glimpse into that future. A future where software development is faster, more efficient, and more focused on delivering real value.
So for our listeners out there, what's the key takeaway from all of this?
If you're building a family of related software products or even thinking about it, you should definitely take a look at IsiSPL. It can automate so much of the heavy lifting, letting you focus on building awesome software.
That's great advice. Well, this has been a really enlightening look at ISISPL. Thank you so much for breaking it all down for us.
My pleasure. Always happy to talk about innovative approaches to software development.
And to all our listeners, thanks for joining us for another deep dive. Until next time, keep exploring.